So diuretics are the drugs which can increase the excretion of sodium and water from the body. So in the exams you will be asked what is diuretic. So the most common answer which will be given is the drug which can increase the urine formation. So the answer should be the drugs which can increase the sodium and water excretion. All those drugs which can increase this, we call it as diuretics. So coming to the basic concepts, how many kidneys, how many nephrons, what is current mechanism, what is the concentration gradient, all these things you might have learned in your lower classes. Today we will be brushing up some of the basic concepts about this venous system. Okay. So to begin with, we'll start with this. The drugs which can act on the renal system, we call them as diuretics, and which can increase the sodium and water excretion. So the first group of drugs we are thinking is about this. The drugs which can act on this thick ascending group of Henle. So these drugs are furosemide, bumetanide, torsemide, ethylenic acid, and indapamide. Okay, these are the drugs which are highly potent. Okay, so we also call them as high filling diuretics. Okay, the drugs which can act on this proximal part, okay, that is the thiazide group of diuretics. We have hydrochlorothiazide, chlorothiazide, benzthiazide, chlorthalidone, and metalazone. The chlorthalidone and the metalazone are rather called as the thiazide-like diuretics rather than thiazide diuretics. The next group of the drugs are the drugs which act as a potassium-sparing diuretics. Okay, those drugs are amloride, triamcinolone, aldosterone antagonist, that is spironolactone, and the active metabolite eplerenone. Then indirectly acting drugs, that is the osmotic diuretics, that is mannitol, glycerol. Then carbonic anhydrase inhibitors, acetazolamide, dorzolamide, brinzolamide, all these are there. So coming to the basic concepts of nephron. So So today I am using this part. I'll just briefly tell about the basic concepts. Okay. So heart receives how much of blood now per minute? Any idea? 4 to 5 liters per minute. Okay. Then how much of this will enter the renal system per minute? About 25% of it. What it should be? Approximately 1 to 1.5 liters. Okay, we put it as 1.2 liters per minute. Okay. And this is only per minute. Okay. You are getting? So each kidney receives 600 ml. Clear? So how many minutes we have? So much of minutes we have. But what is the total urine output per day? Okay. So how much of it is reabsorbed? 90%? Or more than that? More than that. Okay. So this is the simple calculation. All this part is reabsorbed back. Okay. We'll take it that each, we are speaking about now one nephron. Okay, it is receiving about 100 ml. Okay. Now we need to know some of the basic concepts here. Okay, so we have cortex and medulla here. Okay, this will be the cortex, this will be the medulla. So the highest concentration we take it at the cortex will be around 300 milliosmoles. At the bottom, that is inside the medulla, the concentration will be around 1400 milliosmoles. Okay, so what is happening to this concentration? It is going on increasing. Okay, somewhere here 600, the junction you can take it as around 900, somewhere here 1200. Okay, so this is the concentration gradient as the blood is moving inside, okay, and as the urine formation is taking place, there is increase in the concentration once it is going inside. So how it is able to reabsorb back so much of fluid, we need to understand here. So what will be this part of the nephron? Okay, so what will be this part? Yeah, PCT. Then what will be this part? Okay, so what are the important solutes which will be coming inside? Sodium, bicarbonate, water, and also this potassium. Okay, so here when it is going on, what are the cells which can act on this part? Okay, so that those things you need to remember. I'll just rub off this. How this is absorbed inside this cell. Okay, those things we need to know. The basic concept we need to know about is carbonic anhydrase enzyme. So we are now speaking about the basic cell function. Okay, it may be the function of most of the cells within the body. Okay, among these cells, what will be the basic function which is going on? What happens to the sodium and potassium? How sodium and potassium concentration will be maintained inside the cell? Any idea? Where sodium is more? Inside the cell or outside the cell? Outside the cell. How will this happens? What is maintaining that? Okay, so here the sodium concentration inside the cell is always kept at low with the help of sodium potassium ATPase system. Okay, what does sodium potassium ATPase do? If you pull in 2 potassium, pull out 3 sodium. So what happens inside the cell? The cell is always kept at lower concentration of the sodium and potassium concentration is maintained at relatively lower. Even though exchange is taking place, you know this exchange is not equal. That means the cell is having the potential to draw in some of the positive ions from the luminal side. Okay, this we call it as luminal side, and other side we call it as basolateral side. These are the terms which we will be using again and again. Okay, now we are speaking about this basolateral cell on which there is sodium potassium ATPase system which is working. Okay, you are clear? There is a sodium potassium ATPase system which is maintaining the concentration of sodium and potassium inside the cell. Okay, now we told about this carbonic anhydrase system, where that system will come into act. We told that this bicarbonate ion is coming inside here into the nephron. Okay, so this carbonic anhydrase enzyme is present both on the inside the cell and also on the luminal side. Okay, is it clear? So what we told was, due to the presence of this sodium potassium ATPase system, the cells are always kept at sodium deficient end and cell is ready to accept this sodium. Okay, so in order to accept this sodium which is coming here, we have a channel here. Okay, you are getting? We have a channel which will exchange. See, this is always in the form of exchange. Okay, so sodium comes in, one ion of hydrogen goes out. Okay, so we have a bicarbonate here HCO3 plus H which is coming out in exchange of the sodium. We have an enzyme which can work here, that is carbonic anhydrase. So what it can do? Carbonic acid. Okay, so we will start once again. Okay, sodium potassium ATPase system. We are keeping the cell deficient for sodium. Okay, we have the sodium and the bicarbonate ions which are coming here. Okay, so once the sodium comes into the particular site, okay, the cells are acting and that sodium is extracted inside and exchanged to the hydrogen ions. Once this hydrogen ions comes in contact with the carbonic anhydrase enzyme and also this bicarbonate. Okay, what can happen? There can be carbonic acid formation. Okay, that is one concept. How this hydrogen inside the cell has come? You need to have a concept for that. Okay, along with this sodium, bicarbonate and water, we have carbon dioxide also, because blood always contains oxygen and carbon dioxide. Carbon dioxide is a highly diffusible, highly lipid soluble gas. Is it clear? Carbon dioxide can enter any cell by diffusion because of its highly lipid solubility. Okay, this cell always has this water, and due to high diffusibility, the carbon dioxide has entered. Now we have an enzyme. That enzyme is carbonic anhydrase. What it does? It converts into carbonic acid. Okay, it is a bilateral it can do both forward and backward reaction. Okay, here you saw the reverse reaction, there you saw the formation, something like that. Okay, so here once the carbonic acid is formed, it can diffuse itself into bicarbonate and hydrogen. The bicarbonate from the luminal side is taken inside the cell for metabolic reactions. Okay, and this hydrogen is left out. This hydrogen, which is at high concentration, due to the formation of carbonic acid again and again, this will be in exchange with the sodium. Is it clear now? Is the cycle complete? How did we get this carbonic acid outside? How did we get this carbonic acid inside? How bicarbonate is drawn inside with the help of this carbonic anhydrase enzyme. Okay, that is one concept. So next concept here is as we go inside, we have very high concentration. Okay, so God has his own mechanism to conserve these solutes. Okay, what he has done, the white line I am drawing here, you need to understand this region is the one which is completely impermeable to water. Okay, this region is completely impermeable to water unless it is under the influence of ADH. ADH is anti-diuretic hormone. Okay, so that is one concept that is helping in maintaining the concentration. We will come back to it, how it is maintained. I want to tell you about one more group of cells. What we call it here, it is loop of Henle. What it should be, it is going up. Ascending loop of Henle. Okay, so here we told that unless it is for ADH, we cannot have any solutes or solvents, for example water, going out. Okay, and here we are speaking about one more group of cell, that is sodium potassium chloride cotransporter. Okay, sodium potassium chloride cotransporter. Okay, even though it is sodium potassium chloride cotransporter, on the basolateral side we have this what? Sodium potassium ATP system. What it is doing? It is sending in 2 potassium, throwing out 3 sodium. Okay, here we have this sodium potassium chloride transporter. What it does? It is a system which draws in all these things. Okay, sodium, potassium, chloride, everything is drawn in here. The chloride which comes inside, it has specific chloride channels which enters the blood. Okay, which enters the lymphatics and the blood. Then for sodium and potassium, we have this system, sodium potassium ATP system. Okay, so sodium is taken care of and chloride is taken care of. But what about this potassium? Potassium is coming in from this sodium potassium ATP system also, and also this sodium potassium chloride cotransporter. For that we have something here, that is potassium channels. Okay, these potassium channels will throw out this potassium into the lumen. Is it clear till now? Here, sodium potassium ATPase to take care of the sodium which is coming in, the chloride channels which is utilizing it for the bodily systems. Then we have the potassium. Okay, the potassium which is getting accumulated into this cell can be thrown out with the help of potassium channels. Okay, what happens to the electrical balance here? when potassium is thrown out, it is a positive ion. Is it clear? It is a positive ion. Okay. So if it is a positive ion accumulating here into the ascending lumen, there will be electropositivity. Okay. This electropositivity, what can happen? It can obstruct the other positive ions which are coming inside. Okay. So that's why we have something called as paracellular diffusion. Okay. The next concept you need to understand is the electropositivity which is maintained in the ascending loop of a plate, and also about the paracellular diffusion or the paracellular transport which is taking place. Okay, it is taking place due to the electropositivity which is created by the potassium ions which are entering from this potassium channels. Okay, so positive atmosphere. What are the positive ions which can enter here? Those are magnesium and calcium. Okay, is it clear till now? Once this potassium, magnesium and calcium ions enter this part, what happens due to the repulsive activity from those positive ions? They go for this paracellular diffusion, and this is how calcium and magnesium is entering into the body. Okay, this pipeline is the one which is going for formation of the urine. Okay, so we are now speaking about how the positive ions are conserved here. Okay, the magnesium and the calcium are conserved due to the positive environment created by this potassium channels. Is it clear? Okay, we have now spoken about the different things. Okay, the first we spoke about the ions which are coming. What is the cellular gradient which is maintained at the there, and we told about the antidiuretic hormone which is influencing here, and we also told about what is luminal side, what is basolateral side, what is the normal function of the sodium potassium ATP system. Okay, so there are some various other channels. Okay, there are various other channels which are conserving this nutrients. I am speaking about the specific channels which we will be speaking in case of our diuretic action. Okay, some basic concept we are trying to understand, and we have spoken about the sodium potassium chloride co-transport or the SIM4 system. Is it clear till now? Are you clear about this carbonic anhydrate system? How it is doing its function? Okay, so now we will come to the third system, that is the principal cells. Okay, here we have this principal cells, and here we have intercalated cells. Okay, intercalated cells, they have co-transport system, sodium chloride co-transport system. That is, whatever the sodium chloride which is coming here, it will be absorbed by this system one way. Okay, and what will happen to this sodium which has entered? Sodium is under the influence of what? Once sodium enters the cell, what will happen? We have sodium potassium ATP system. Okay, so sodium potassium ATP system, it will transfer this sodium. Again, chloride has specific channels for it which can absorb back this chloride. Okay, this intercalated cells is also under the influence of this parathyroid hormone. Have you heard of it? Parathyroid hormone, PTH? Yes. What it does? It is involved in conserving of this calcium also. Okay. Under the influence of this, we have calcium conservation. How this happens? Okay. Under the influence of this parathyroid hormone, we have calcium channels at the luminal end, and the calcium sodium and it transporters. Okay, this calcium sodium transporter, what it does, as the sodium chloride which has entered, part of this sodium is exchanged with this. Okay, here once calcium comes in, this calcium should go in. what it does, this calcium sodium channel, okay, this will turn back this sodium, okay. The whatever the sodium which is there, it will be helping for calcium reabsorption, okay. The sodium which has entered into the blood system, okay, or the blood, it will be transported back in exchange to the calcium, okay. That is one mechanism where the calcium absorption is taking place. One is by paracellular diffusion, okay, due to the electropositivity, and another mechanism is under the influence of parathyroid hormone, where at the luminal side we have the calcium channels, and that calcium, once it enters the cell, it will be taken back to the basolateral side, where we have sodium calcium exchange system. Is it clear till now? Yes? Okay. So we have the principal cells now. Okay. We spoke here about the electropositivity which is created. Now we are speaking something about the electronegativity. Okay. How this electronegativity will happen, I will tell you. Okay. As the blood enters, okay, as the urine formation goes further, we have some amount of calcium, some amount of other ions which are entering here in the principal cells under the influence of this aldosterone. Okay, aldosterone is what it does. What it does? Aldosterone. Aldosterone, here it can produce aldosterone-induced peptides, AIPs. Okay, AIPs can increase the sodium channels. That means it is involved in conservation. It is a mineralocorticoid. Okay, it is a mineralocorticoid. It is a conserver of this mineral sodium. Okay. Stand. Good. You are done. Second is third person. Yeah? Oh, sorry. So here we are speaking about the principal cells which are under the influence of this aldosterone. Okay, aldosterone, under the influence of this aldosterone, it produces aldosterone-induced peptides. These aldosterone-induced peptides, what they can do, they can increase the number of sodium channels at the luminal side. Okay, so this sodium channels at the luminal side, what they will increase the sodium channels. So sodium enters in, more amount of sodium enters in, more will be the action of this sodium potassium ATP system. Is it clear? Sodium potassium ATP system, which is working at the basolateral side. Okay, so what will happen to the potassium concentration inside the cell? More potassium, okay, because more amount of sodium is entering in, more action of the sodium potassium ATP system, and there will be more amount of potassium inside the cell. So once this sodium is entering more and more inside the cell, what can happen? We also have a major constituent, that is bicarbonate. Okay, so once urine formation goes on, here as it comes to around the tubules, collecting tubules, there will be more electronegativity. This electronegativity is created due to the presence of bicarbonate ion and less of this sodium ions. You are getting it? Yes? Okay. So this is the basic concept. With this, we will build our talk. So what are the drugs which are acting here? We have carbonic anhydrase system, carbonic anhydrase inhibitors. Okay. You can see here the drugs which can act on this carbonic anhydrase inhibitors, that is acetazolamide. Okay. Then we have the osmotic diuretics which can act on this loop. Then we have this loop diuretics which can act on this sodium potassium chloride cotransporter. Okay. Then we have this drug thiazide which acts on this distal convoluted tubule, that is sodium chloride cotransporter blocker. And Then we have the drugs which can act on this collecting tubules, that will be the protection sparing diuretics. Okay? All these channels will be blocked. How they act, how the action will go, we'll learn it now. Okay, so you got to know where our system is working. Okay, so carbonic anhydrous inhibitors, thiazide group diuretics, osmotic diuretics, loop diuretics, and the loop diuretics are also called as the high ceiling diuretics because these are the drugs with high efficacy. Okay, then we have on the collecting tubules, the drugs which will be acting with are the potassium sparing diuretics. Okay. So, loop diuretics are the high ceiling diuretics. Okay, the first drug which was used it was our methacranic acid. Okay, so methacranic acid, as you know, we have a system of limbic system. Okay, and also the semicircular canals which maintains the balance. Okay, you might have learned about this in inner ear and its mechanism in maintaining the balance. Okay, so if